Can you listen me or not? Anyone who can write? आपको मेरी आवाज आ रही है? Okay, okay. So we can wait for 2 minutes. Let's the others to join. Then we can start the today class. Okay. 2 मिनट के लिए वेट कर लेते हैं क्योंकि अभी only 6 students are have joined. So we can wait for 2 minutes. Let's others to join. Then we can start. Okay. Okay, so we can start the today lecture. So Rishikesh has asked something that, so what is the loss function, cost function, error, and MSE? No, these are not the same. Okay, but but related to each other. Okay, so today I will tell you what is the loss function, cost function, error function, and MSE. Okay, you can hear me, Rishikesh? Rishikesh, you can hear me? So today I will explain you about the loss function, cost function, error, and MSE. We cannot say these all are same, but they are related to each other. How they are related to each other, that also we will see. Let me connect the. Minima minima will be find after. Try to understand minima we are finding with the gradient descent. Okay, that I will come to point. First of all, you understand. I will come to that point. Rishikesh, don't worry about that. First, I make you explain the difference between all these. Okay, can you see the screen? Okay, so first try to understand this loss function. When we talk about the loss loss function, then another one you have asked about the cost function, then you have about the error, and then you have asked about the MSC. Now, if someone will ask you all these are same, no, these are not same. Okay, but they are related to each other. But related to each other. So how they are differ? So first of all, you have to understand the loss function. Okay. So whenever we are talking about the loss function measures the error for a single train. You got the point? It is for the single train. Okay. And it qualifies how far the predicted value is from the actual value. You got the point? What I am telling means that loss function is telling the single training. Okay, error for the single training. It is the error for the single training, and it is telling that how far this is the predicted by y cap, and this is the actual. How far it is from the how what is the difference between them. Okay, so for this training single training error, we have to use what MSE. Okay, are you clear with this? We have to calculate for the error means single training error. We have to calculate only through the MSE, that is the mean square error. And what is the formula for that? Ly and y cap is equal to y cap minus y whole square. Okay. Now what is another one, another loss function? That is the cross entropy. So we can save this today lecture. Today's is, I think, 21st March 2025. So it is slide 1. And another one is that we can calculate the loss function by MSE, that is L y cap comma y is equal to y cap minus y whole square. Second one, that is the, what is the another cross loss function? That is the cross entropy. Okay, entropy loss. Mainly it is used in the classification problem. MSC कहाँ यूज कर रहे हैं? रिग्रेशन में, और क्रॉस एंट्रोपी यहाँ पे यूज कर रहे हैं. तो इसका फॉर्मूला क्या होगा? दैट इज व्हाट इज द फॉर्मूला फॉर दिस? दैट इज L y comma y cap is equal to minus y log of y predict plus 1 minus y actual, and that is log of 1 minus y predict. This is the formula for it. Okay, so by these two ways we can calculate the loss function, and loss function is always calculated for the single training. Okay, now come to another part, that is the cost function. Okay, so it is the average loss over the entire data set. Okay, are you clear with this? The difference, it is on the single training data set, it is over the all entire. Okay, which it is helpful in the optimization. Means what? It is used for the optimizing the model. Parameters. Okay, now if we have to calculate, then what is the symbol for that? That is the j theta is equal to 1 by n summation of I is equal to 1 to n, and that is the yi cap minus yi square. This is also what? MSC के थ्रू भी निकालते हैं. You got the point, Rishikesh? अब आ जाओ एरर क्या है? Error is simple, the difference between predicted and the actual. ठीक है, इस दोनों के डिफरेंस को हम एरर कहते हैं. सिंपल एरर, जिसका हम सिंपल फॉर्मूला लिखेंगे, एरर इज इक्वल टू y माइनस y कैप. Okay. Yes. That is the part is लॉस फंक्शन जो है सिंगल ट्रेनिंग डाटा सेट के लिए यूज हो रहा है और जो कॉस्ट फंक्शन है तो सिंगल पहले तो हम सिंगल ही निकालेंगे फिर सिंगल के एक एक सिंगल का निकाल के फिर उसका एवरेज करेंगे तो क्या हो जाएगा कॉस्ट फंक्शन हो जाएगा ठीक है ये लॉस और कॉस्ट जो है आप मेनली डीप लर्निंग में पढ़ोगे जब आप बैक प्रोपोगेशन में जाओगे और मीन एमएससी क्या है it is the specific type of loss or cost function used for regression. Understood? So it is also what when we talk about the MSC, it is when we divide by 1 by n means what? 1 by n, 1 to n, yi minus yi whole cap square means that it is calculating the average square error across all samples. Average square error across all samples. Okay. Are you clear with this? किसी को कोई डाउट है तो पूछ सकता है इसमें तीनों चारों में समझने में कोई दिक्कत है तो ये चीज आपको मिनिमम डिफरेंस मालूम रहना चाहिए Okay, I will upload. Rishikesh, I will upload it. Now your second question is what? Sir, if we skip 1 by n from the cost function, then our minima will be affected or not? See, when we talk about the minima, it will not be affected. Okay, minima will not be affected, but the thing is that it will affect the gradient magnitude and also the optimization speed. You understand, Rishikesh? हमारे मिनिमा पे कोई इफेक्ट नहीं पड़ेगा पर उसके जो मैग्नीट्यूड है उस पर असर पड़ेगा और ऑप्टिमाइजेशन के स्पीड पे असर पड़ेगा ठीक है आर यू क्लियर विद दिस और कोई डाउट है और कोई इस तरह कोई कंफ्यूजन है देन यू कैन आस्क यस but we can go but our it will affect the speed because when we not divide by n then what happens its value will be more ओके छोटे वैल्यू पे इफेक्ट नहीं पड़ेगा पर जब हम बड़े वैल्यू पे जाएंगे then whenever we have the more number of samples larger data set okay तो आप समझ गए क्या है जब whenever we are talking about the loss function तो इसमें हमारा क्या होता है, लॉस फंक्शन हमारा क्या करता है, मेजर्स द एरर फॉर ए सिंगल एग्जांपल, मींस इंडिविजुअल डाटा पॉइंट के लिए। जब हम कॉस्ट फंक्शन की बात करें, whenever we are talking about the cost function measures the average loss over the all examples, means whole data set के लिए। एरर की बात करें तो एरर क्या है, डिफरेंस बिटवीन द एक्चुअल एंड प्रेडिक्टेड वैल्यू, ठीक है। एंड एमएससी क्या है, दैट स्पेसिफिक लॉस एंड कॉस्ट फंक्शन दैट स्क्वायर एरर एंड एवरेज देम, ठीक है। तो ये मुझे लगता है आपको क्लियर हो गया होगा, ठीक है। Yes, that I'm telling you. मीन्स जो हमारा जो ऑप्टिमाइजेशन का जो स्पीड, अगर 1/n नहीं करेंगे, n टाइम्स करेंगे, तो हमारा जो स्पीड है वो स्लो हो जाएगा। 1/n से क्या हो रहा है कि हमारा जो स्पीड है वो मेंटेन रह रहा है, ठीक है, और मैग्नीट्यूड भी। ओके, आर यू क्लियर विद दिस? सो नाउ वी विल स्टार्ट विद द दैट इज अ लॉजिस्टिक रिग्रेशन। ओके, नाउ आई थिंक जो हमारा लास्ट क्लास में लॉजिस्टिक रिग्रेशन ही चल रहा था, so today we will cover the logistic regression part. So we can see this, this is what, this is the linear regression part, cost for the linear regression part. And second one, when we talk about the second one, that is the logistic regression. Gradient, I will explain that. Okay, मल्टीपल कॉलम के लिए मैं आपको एक्सप्लेन करूंगा, okay, because once it will be completed, then in one experiment I will explain all this for the multiple column. Okay, so this is the linear regression part, and how it is converted into the logistic. It is the S curve. In the linear regression we have the straight line, whereas in the logistic regression we have the S curve. How this S curve will be achieved, that is what we will see that. So linear regression, when we talk about the linear regression, predicts the numerical response but not suitable for predicting the categorical variables. Okay, so linear regression, when we talk about the linear regression, it is okay with the continuous value. Numeric response means what? Continuous. But it is very difficult to predict for the discrete value. Okay, so when the discrete value will come, means that we are discussing about the classification problem. Okay, so we can say that logistic regression is suitable for the binary classification as well as the multi-class classification also. So for example, we can see the scenarios where the categorical variables are used, like is the email is a spam or not. The answer is yes or no. So it is a categorical dependent variable is a binary response, that is yes or no. The student should be admitted or not is based on the entrance exam marks. The student pass or fail. Okay. So how does the logistic regression algorithm works? So take one example. We can take one example that there is an organization want to determine an employee salary, increase salary based on their performance. For this purpose, a linear regression algorithm help them to decide. Plot a regression line and consider the employee as the independent variables and the salary increase as the dependent variable. Okay, it makes our task easier. Now, if what happen if the organization want to know whether an employee should get a promotion or not based on their performance. Okay, earlier one is that, what is that? Okay, this is what the salary hike. Now this is what that performance पे उसे performance मिलेगा कि नहीं मिलेगा. So the above line graph would not be suitable for the case. ये जो straight line है, ये straight line is not suitable. Okay. Based on this employee rating, we can predict the salary of an employee. But to perform, to get the promotion, yes or no, that is a categorical data that we cannot handle by the linear regression. We have to handle by the logistic regression. So that's why we make this graph. So we clip the line at 0, 0 and 1 and convert into the sigmoid curve, that is the S curve. And based on the threshold value, the organization can decide whether an employee will get a salary increase or not. So threshold value may be 0.50. If a person performance rating is getting above 0.5, means that he will get the promotion. If a person is getting the rating below 0.5, means that he will not get the performance. That depends upon you. That is the, you have to fix the threshold. There is another method to calculate the threshold value. Okay. There are different methods are there by which we have to calculate the threshold value. Okay, Rishikesh, are you clear with this? There are the different methods are there. Okay, so that is the whenever we are talking about the threshold value. So in the, when we talk about the machine learning, there is the ROC curve is there, precision and recall curve is there. So based on that, we can use to justify find the threshold. Okay. So here, what is that? We have fixed one threshold value, that this is the threshold value. If we see that the threshold value, in the threshold value, more employees are coming, we can increase also. Okay. So here in this problem, when we talk about the threshold value, that is the 0.50. Okay. Clear, everyone? Everyone. And for the threshold value, you can use the that is the statistical means method. That is the mean and standard deviation method. Okay. Then percentile method. There are also there percentile methods are there. Then there is also some methods I forgot, that is the mean absolute deviations. Okay. These are the different methods. So Rishikesh, you, or everyone, you can go through what are the different methods. I just try to you. What are the different method to calculate the threshold value? Okay, so can you go through this? You can find there are different methods are there. That is the, when we talk about the statistical method, there is the mean median mode is there. Then percentile method is there. Then we have the MAD, that is the mean absolute deviation method is there. And when we talk about the machine learning, there is the ROC. Okay, ROC curve is there. Precision and recall curve is there. Okay. and another one F1 score maximization is there. So these are the things are there by which we can calculate the threshold value. Okay. Now, so this is the this curve is there. How, but how it graph will curve? Okay, I will come to this point also. First, we will see the sigmoid function, then we will see the proof, then equations. By the based on the equation, you can see this. Okay, so here we can see working principle. So to understand, we have to cover the odds of success. Okay, so what is the odd of success? When we talk about the odd of success, means that probability of an event happening to probability of it not happening. So the odd of success ranges from 0 to infinity, and its probability lies between 0 to 1. You got the point? You clear with this line? The values of odd range is 0 to infinity, but the value of probability lies between 0 and 1. Now, when we see the equation of the straight line, that is the beta naught, that is the y-intercept plus beta 1 into x. Okay. So now predict the odd of success. We take the log on the odd formula. Okay. So यहाँ पे हमने log लिया. Okay. Is equal to beta naught plus beta 1x. Are you clear with this equations? यहाँ पे अब हमने क्या किया? exponential both side. So we know that e to the power log n px by 1 minus px is equal to e to the power beta naught. What you are asking, Rishikesh? How it will come? क्या p? What you want to ask? Yes, p is equal to 1 minus p. P is that the probability of event happening, and p 1 minus p is the probability of event not happening. इसमें क्या कंफ्यूजन हो रहा है? ये क्वेश्चन समझने में दिक्कत हो रही है. p is by 1 minus p. Anyone who is getting the confusion with this? ओके तो यहाँ पे हमने क्या किया? एक्सपोनेंशियल लगाया बोथ साइड में. ओके तो जब यहाँ पे एक्सपोनेंशियल लगाया तो क्या हम जानते हैं e पावर log x इक्वल टू x हो जाता है. तो यहाँ पे हमारी जो वैल्यू है, जो भी वैल्यू है, ये दोनों वैल्यू पी एक्स 1 माइनस पी एक्स इक्वल टू ई बीटा नॉट प्लस बीटा 1 एक्स हो जाएगा. सो यहाँ पे हम क्या किए? इसे y लिए. we have taken as y. px by 1 minus px is equal to y. So now we can say that px is equal to y into 1 minus. ठीक है? Are you clear with this line? Again, I am explaining you how it is. I am derivating the equation, that is 1 by 1 plus e to the power minus z. That equation I am driving. Okay, again I am telling you. Also, odds of success equation, you know, that is p by 1 minus p. And we know that the equation of the straight line is equal to beta naught plus b1 into x. So here we can say that Yeah, here now to predict the odd of success, we take the log on the odd formulas. So we have taken log px by 1 minus px is equal to, that is the y. That is y is what? That is the beta naught plus beta 1 x. Now we are taking exponential on the both side. So e, that is e ln px by 1 minus px is equal to e beta naught plus v1 beta 1 x. And we know that it is e ln x is equal to x. So that's why it will be the x part. So it is the px by 1 minus px is equal to e to the power b naught plus b1 x. Now this part, that is a e b naught e to the power b naught plus b1 x, we can take as a capital Y. We can take as a capital Y. So now the my formula will be px by 1 minus px is equal to y. Now we can do the cross multiplication. So px is equal to capital Y into 1 minus px. Okay. So now we can take that px plus ypx is equal to y. Okay. Are you clear with this? Now px, that is a ypx, we can take the common of that. So we can get the px into 1 plus y is equal to y. Okay. Because here we know that px, this part. So px is equal to y by 1 minus y, capital Y. Now we keep the value of y. That is what? Y value is e b naught plus b1 x into x by 1 plus e to the power b naught plus b1 x. Okay. When you do the, when we cut this, then what we are getting? 1 by 1 plus e to the power minus b naught plus b1 x. Okay. Are you clear with these equations? अगर कोई दिक्कत है तो 2 मिनट आप देख लो इक्वेशन का डेरिवेशंस. Everyone, kindly go through this derivation part. तो यही हमारा क्या है? This is what? This is a sigmoid function. Okay. आप इस इक्वेशन को ड्राइव करोगे तो आपको स्टेप बाय स्टेप में आप दिखोगे, इजीली आ जाएगा. From this equation, how it is came? This equation, you understand that? ये जो px है, ये जो px y by 1 minus 1 by pi 1 by y से यहाँ पे हम लोग कैसे आए? Are you clear with this? Cut part repeats. What? Which cut part you want to ask? Okay, again I am explaining you. So we are taking the odd of success, that is the p by 1 minus p. So its value is ranges from 0 to infinity, and the value of probability lies between 0 to 1. We can take the equation of the straight line, that is the y is equal to 1 b1 beta 1 into x. Oh, wait a minute. Now it is visible. Now it is visible or not? तो यहाँ पे हमने क्या किया, ऑड ऑफ सक्सेस लेके और इक्वेशन पे स्ट्रेट लाइन लेके दोनों को क्या किया, लॉग लगाया, और क्या किया यहाँ पे log px बाई 1 माइनस पी एक्स इक्वल टू बीटा नॉट प्लस बीटा 1 into x. Then we have applied the exponential on the both side, that is the e ln px by 1 minus px is equal to e to the power beta naught plus beta 1 x. Then what we have taken, we know that e ln x is equal to x. So the en part will be removed. So px by 1 minus px is equal to e to the power beta naught plus beta 1 x. Now what happened? We have taken e to the power beta naught plus beta 1 x as a y, capital Y. So px by 1 minus px is equal to capital Y, and px is equal to cross. Then finally we can take the px on one side. So px is equal to y by 1 minus y, y by 1 plus y. Now we keep the value of y, that is what, e to the power beta naught plus beta 1 into x by 1 plus e to the power beta naught plus b1 x. Now what we will do, we will divide the both numerator and denominator by the same value, that is the e to the power beta naught plus b1 into x. Okay, so the above part will be 1. Okay, so are you clear with everyone? Are you clear with this? So from the above equations, when you put the values, we can get the curve. Rishikesh, are you clear with this curve? How this curve has been plotted? Everyone is clear with this plot, how this plot has been how this curve has been plotted. Okay, so now we are coming to the numerical problem, one numerical problem. So we can say that uh, the student data set has a entrance marks based on their historic data of those who are selected or not selected. So based on the logistic regression, the value of learned parameters beta 1, beta naught is equal to 1 and beta 1 is equal to 8. Assume maximum marks of x is equal to 60. Okay, are you clear with this equation? This problem, everyone, are you clear with this problem or not? बीटा 1 बीटा नॉट और बीटा 1 की वैल्यू दी हुई है, x की वैल्यू दी हुई है. Now you can listen me. तो देखो इस प्रॉब्लम में हमें बीटा 1 की बीटा नॉट की वैल्यू, some internet issues, internet is little bit slow. Can you see the screen? So beta naught value is 1 and beta naught 1 value is 8 and x value is 60. So you can put we can put the value in this equation. So we have put the value in these equations, and whatever the px will come, and we have fixed one threshold value. If it is less than that threshold value, means that it is not selected. If it is greater than that, we can say that it is got selected. Now solve this problem. Everyone solve this problem. Everyone try to solve this problem. The data set of pass or fail in an exam of 5 students are given in the table. Use the logistic regression as a classifier to answer the following questions. Calculate the probability of pass for the student who studied 33 hours. And at least how many hours student should study that makes he will pass the course with a probability more than 95%. Assume the model suggested by the optimizer for the odd of passing the course is log odd is equal to minus 64 plus 2 into hours. So calculate the probability of the pass for the student who will study 33 hours. Sorry. Anyone got the answer? Anyone? Okay, so we can see the sigmoid curve is this one. What is z? Z is equal to minus 64 plus 2 into 33. That is the value is 2. Okay. Just so that is the minus 64 plus 2 into 33 is equal to 60 minus 64 plus 66 is equal to 2. So the probability is what? That is 1 by 1 plus e to the power minus 2. So it is 0.88. So if the student study 33 hours, then there will be the 88% chance that the student will pass the exam. Okay. Now second part. First part you have understood? Everyone, first part. Second one. At least how many hours student should study that makes he will pass the course with the probability more than 95%. So P is equal to 0.95. So we have to find the value of Z. So just we have to keep the value 0.95 into 1 plus e to the power minus Z is equal to 1. So by this we can calculate the value of Z. That is the 2.94. So this is the final solution. So Z is what? 2.94. So 64, that is the Z is equal to minus 64 plus 2 into hours. That is 2.94 is equal to minus 64 plus 2 into hours, and we can calculate the hours. Okay. Are you clear with this both problem? सबको clear है? So in the end term, one question will surely come from this numerical. एक numerical तो आएगा ही इससे. Okay, so kindly solve this. Kindly go through this problem. Try to understand how, what they are asking and what we have to calculate it. In the first question, when we see, they are asking about the P, that is a probability. And in the second question, they are asking about the hour. So first we have to calculate the value of Z, and in Z we can this equation, that is log x is equal to minus 64 plus 2 into hours. Yes, surely I will upload this. Just now only I am uploading. Wait, I will upload now. In the drive you can find it. I have uploaded the PPT. Last class slides. Which one, lab one or the last class? Can you tell me the date? Which date? Anyone can tell me the date? Which date it is? It is 19th. Okay, I have uploaded, Rishikesh, I have uploaded all the file in the experiment number 8. Okay. जितने भी फाइल है मैंने आपको okay, both I have. Okay. So with this we can end. If anyone has any doubt, you can ask. Else we can stop today lecture till here. किसी को कोई डाउट है? See, logistic regressions plays an important role. That's why you can go through that. Not only logistic regression, but regression also. Regression is one of the important topics. Now, so I think we have covered the supervised learning part. Supervised में दो था, that is what? That is the regression and classification. So we have, I think we have already covered the classification problems. That is the, we have covered which topic? We have covered KNN, we have covered the naive base, then we have covered the next one, that is the decision tree. And in the regression, we have covered in the regression, we have covered the linear regression. Then we have covered the logistic regression. Now in the next class, we are going to move on the next part, that is the unsupervised learning. So in the unsupervised learning, we are going to see about the clustering and the dimension reduction. So first we will see the dimension reduction, that is the PCA. So in the next class, we will start with the PCA. Okay. Can I stop the recording part?